Good evening. This is the Chucktown Wind Report update. It is about 9:20 on Wednesday night, August the 26th, 2015. So a couple things to talk about. Number one, our forecast looks like it's going to be changing for tomorrow. I know we talked about yesterday in the extended outlook that we were going to keep southerlies along the boundary. That's going to be hugged in along the coast, and we are seeing the boundary stall along the coast. However, tomorrow, this high pressure to the north looks like it's going to build a little bit stronger down into the southeast and just barely nudge that frontal boundary offshore, especially for South Carolina and southeast North Carolina, possibly even into northern Georgia. It looks like it's going to get hung up across southern Georgia, maybe northern Florida, but for the most part, we should see a lot of this boundary activity clear the coast. Now, this high pressure, we see two different lobes right now. As it drops down into the Ohio Valley, I'm expecting one central high pressure center to develop, and we actually see an increase in strength. So right now we have 1,020 millibars. We could see 1,022 and possibly 1,024 millibars, and what that means is that these northerly winds coming down will increase the pressure gradient behind the boundary and increase speeds overall. So southeast North Carolina looks like it's more prone to getting the higher speeds of all three states tomorrow, and I'm expecting South Carolina, we should see that northeast flow come down and then bend east-northeast as backdoor sea breezing occurs. So when we get sea breeze oscillations off of these northeast winds, the land heat and the sea interaction with that direction of wind and that cooler air spilling down causes that wind to bend or shift into the coastline. So that's what causes that acceleration effect, and we'll do a topic on that another time, but for right now, we should expect that boundary to clear the coast. Okay, so let's take a look at our infrared loop, and not seeing a whole lot of activity right now. Most of the activity, any thunderstorm activity that we're seeing, any higher cloud tops or vertical stacking, these clouds are getting blown off to the northeast from the southwest. So we have, along that boundary, we have this zonal flow going on, and even up at the mid to upper levels, there's some wind shear going on. So not a lot of storm activity is able to hold together. I saw some cloud tops earlier where the tops of them were really just sort of strung out to the northeast of where the central area of storming or the central area of convections were trying to fire off. So that's what's been keeping those at bay. Rather weak and dry for the most part. Okay, so if we look at the southeast region, we'll come back to Charleston here in just a minute. I want to look and make sure to see where some of these northeast winds are actually peeling down. So if we let that load, we're seeing that up in North Carolina. We're seeing 15 knots, 16 knots, Kill Devil Hills, and as we get down into the Outer Banks, we start to see 13, 12 knots. Some moderate northeast, east-northeast winds are already starting to push down, so that means the frontal boundary has cleared that area. And as we get down into the south, Cape Fear, we're seeing 16 knots, 15, 16 knots near Wilmington and Cape Fear area, where that boundary has cleared that location as well. So it looks like the boundary is sort of meandering in and out of the coastline. Now we get into Charleston, we see clearly that the frontal boundary is hung inland, and we can see Somerville amongst corners showing this easterly wind behind the boundary because it's that close to our coastline. And just ahead of it, where this very mild low-level jetting is occurring, we're seeing 9 and 10 knots. So pretty quiet out there for the most part. Nothing to really worry about, but just a feature where you can remember that we had a very dry cold front come through today, and then into tomorrow it should push off the coastline. Okay, so let's take a look at, I want to take a look at the tropics. Okay, so here's Erica, and she's passing over the Leeward Islands right now as we speak. And the main feature driving Erica and what the computer models are picking up on is this large ridge of high pressure in the North Atlantic. Now, the central high pressure for this right now is over here, and this is more of a Bermuda Azores high pressure center. And then as we get over here, this becomes the Bermuda high. So we're going to focus on the Bermuda high because right now the easterly trades are coming across underneath it and actually driving the winds up this way. So when we talk about the subtropical ridge, we can include all of this together as a subtropical ridge, and you can see how it's sort of flattened out, due in part by this upper trough up this way, and then we have Erica down to the south and a couple of tropical waves. So this is not a very robust high pressure out here in the North Atlantic, and when that happens, you get a flattening of the isobars, which this is an isobar right here, and it creates, this is the ridge axis, so it's the actual point furthest where the center of the high pressure is extending out to the edge of this isobar, and that's called the ridge axis. Now, this ridge axis is a very pivotal point for winds, where winds are coming up from the southeast below it. They're coming up directly from the south right along it, and then they kind of curve up and over from the south, southwest, and southwest as we get north of that ridge axis. So that's your subtropical ridging effect that we have. Now the closer that this ridge axis comes to the coastline, then the weaker the pattern, and that's what we had somewhat had today. It was a little bit further removed, so it wasn't quite the weakest pattern. The models have been building Erica to follow just along this path, just along the ridge axis, or heading towards the ridge axis. And I think the models are probably a little bit more just north of Hispaniola and up above Cuba and towards Florida, and then up the Florida coast. It's very, very much following in the kind of guidance from this subtropical ridge that is building in from the east. Now, earlier models detected that this ridge would build stronger and the ridge axis would keep going into the coastline, and then we have this Ohio Valley high pressure up here, and that was all going to join as one large ridge and steer Erica a little bit more to the west into the Gulf across Florida. However, I think the models are starting to detect that this ridge may not be as strong as once thought. So this ridge may stall out right here. It could push a little bit further to the west from the east, and then that will be the avenue that Erica is going to follow. Now, the one main feature that we're going to be watching is this frontal boundary out here. This is going to be the maker or breaker of whether or not Erica makes landfall. And there's another feature in continental United States that we'll go into in just a little bit. For right now, how strong this trough remains offshore and how long it remains offshore could be the maker or breaker. So right now the models are calling it weak, but that could change if more energy is allowed to develop along this boundary, especially since it's just south of high pressure. Sometimes we get these low pressures to spin up along the boundary, and you can actually get another tropical system out here, especially with the water being so warm. So it's something to watch very much, especially on these tail ends down here where the high pressure is really building down into it. You can get any low pressures that develop along the boundary can get a little extra spin from the north, especially with high pressure coming up from the south. This might be a very ripe area for even where it would typically be a hotbed of activity, but with Erica coming into the area, it's probably going to take any juice from anything that's developing or sort of merge whatever's there. So it's just something to watch. If we go to, I want to take a look at the rainbow top imagery. Now we have a large flare-up of convection around, appears to be around the center right now, and it means that there's a little bit of maybe some possible reorganization going on. There is some upper level shear, and if you look over here to the northwest quadrant of the storm, at first you can see the cloud tops being blown off to the northeast, and then that settles down. So some of this shear may be relaxing just a little bit tonight, but it could crank back up tomorrow. Now if we look at the visible imagery, a couple things I want to show you on this. Now, number one, the outflow is starting to look a little bit more impressive tonight, just based on this latest blob of convection that has flared up over what we think is the center. However, I want to point out one little thing. Number one, this is the area of low pressure at the surface. All right, so this area back here, where it looks like it could be the center, that's not it. The actual center is this way, and it actually went ahead of the convection earlier. So what we have here is we have a displaced low pressures. In order to have a successful hurricane, you have to have low pressure coming all the way from the surface and all the way to the top out into the atmosphere. So if we look at low pressure, we think of it as a funnel, like where an eye would be for a hurricane. You have your winds that are converging towards the center, and then they're going up and out of the surface low pressure. So an ideal hurricane would have this low pressure, this air going up and out, and you have this really nice outflow. It creates great symmetry for the storm, and it also creates high pressure aloft out ahead of it that can help actually encounter and defend it from some upper level shearing. But that's a whole different story. Right now what we have is we have low pressure at the surface, and then the mid-level low pressure is trailing behind it. So we have something like this, and then even at the upper levels it sort of spreads out, and so what you're left with is you don't have a very well defined area of exhaustion. And with that, in order to have a really good outflow for a storm, you have to have good exhaustion for a storm. And when you have something like this, it's a kink, it's a displaced mid-level low pressure above the surface low pressure, and it's not very good for development. So you have one here, and then you have one trailing behind it. So that's one thing that Erica is going to have to overcome, is it's going to have to do some reorganization and restructuring of that surface low in order to meet the upper level low and make that all jive together. So if we look at the earth.nullschool.net map, we can see the surface low here and spinning. I'm going to go ahead and just pop the circle on, And I'm going to go up a little bit higher in the atmosphere, and I'm going to go up to about 700 millibars. That's about 9,000 feet. And let's see what happens. Okay, so at that level, the center is still staying very close to the surface. And as we go to 500 millibars, this is even higher up, you can see where that level of low pressure, the mid-level low pressure and upper-level low pressure are displaced. It's way back here behind it. And if we go even further up, probably won't even register because that's where the exhaust is. But you can see where the center is. And the one good thing about this is that there is an upper level high pressure ahead of the storm that the outflow has created. So that is probably helping to defend it from some of that upper level shear that was going on earlier. And it looks like the environment is a little bit more relaxed. If you see this clockwise rotation here, you can see there's this upper level shear coming and the storm's heading into it, but it's able to sort of redirect. So the outflow for the storm actually has some good potential for developing the storm a little bit more. But as we get a little bit further over towards Puerto Rico, that shear environment gets a little bit stronger, and she's got a lot to go through going across the Puerto Rico and northern Dominican Republic and Hispaniola. But as we get into the Bahamas, things change. I'm going to go ahead and look at the latest tracks. Now, these are all apt to change. This is just a snapshot of what the models are reading right now, and we see how close this storm comes to the southeast coast, and they're starting to trend on a recurve out to sea, and that's based on going around that ridge, that Bermuda Ridge that's out there. Now, the latest intensity models, there's a little bit of a split. You have some models that go up high in intensity to Category 3 and Category 4 at about 120 hours, and that means once it gets to the Bahamas and starts traveling up the Gulf Stream, she could intensify very quickly. That might be a little bit exaggerated. Some of these models might be a little bit more realistic on a Category 1. Category 2 would not be out of the question, but there is a split. There is some disagreement in the intensifications, and those change quite a bit. So there are a lot of factors involved. Now, if we look at the model runs this is from the 6 o'clock runs from the GFS. Now, this is an important model to watch because it's one of the major ones. This is for 6 a.m. Wednesday on September 2nd, and this brings it very close to our coastline at 992 millibars, which that could potentially be a Category 1 hurricane. And any lower pressure than that, we're looking at Category 2. All right, so that's the GFS model, latest run for that. The models have not been in total agreement until just the last couple of runs. We started to see the GFS start to agree with the Euro model, and if we look at the European model, this is from 12 o'clock today. It brings it almost in the very same vicinity. And then if we go one more over to 192 hours, we see that the model actually brings it a little bit more offshore. It's a little bit too early to tell if the storm is going to recurve out to sea and hook out and about, but at least the two models are in agreement that we're going to have to really keep an eye on this storm for the southeast coast for now. The next update for the Euro model won't be until midnight, so I'm using the one from earlier today. The latest GFS was from 6 p.m. Okay, so let's take a look at the sea surface temperatures. All right, I'm running this from August the 6th all the way until present. And if we see, watch this area of the Bahamas because you can see how it's warming up substantially from what it was before. I mean, it may just be a few degrees, but that's just enough to make it a hotbed for activity right in here. For this, when the storm moves over the Bahamas, there's going to be this area which is really juicy. There's not a lot of upper level shearing going on. It's a very favorable environment for any kind of storm to sort of develop even further, and that's going to be sort of a telltale for whether or not this storm intensifies. So let's go back to the surface map. I did want to talk about this area right here. Now, when we talk about a storm coming up towards the southeast coast along this ridge, here's the ridge axis, we want to look and see what the other mechanisms are. Sometimes we have a frontal boundary that can pull down into the United States and pull these storms out to sea. We don't have that. The only shot that we have is this trough right here, this frontal boundary that looks to stick near the coastline. But this little area right here, this is what's called a shortwave trough, and it's going to be heading this direction behind this high pressure as it moves off to the east. Now, what it looks like is this. It's sort of a bend in the atmosphere along the jet stream, and what you have is you have a lineup of isobars that bend down into the southeast. Now, if this bends down far enough, this storm pinched between the high pressure ridge and the short wave of activity will follow right through it, and the short wave will definitely have an effect. Now, if that doesn't happen, then it should be able to follow to the north. Now, the stronger the storm's going to get, probably the more north it's going to go, just because it's going to be getting more forward motion and it won't have so much effect from this weak ridge axis over here. So that's kind of a thing to think about. You know, this area right here, as it travels off to the east, could have its effects. So we have that plus this trough plus this ridging, and these are all the steering mechanisms for Erica right now. Well, mainly the ridging, and then this trough could be our only defense against this storm as she draws nearer to the coastline. There's no definite of where it's going to make landfall or if it's going to make landfall from here to here, but for right now we should be on guard for it and watching the models to see if there's going to be any close calls for us, because even something out here on a category 1 or 2 could have some pretty strong effects along the coastline, especially if the eastern side of it builds, or the western side of the storm builds to where the wind field is able to affect the coastline and we get a storm surge and the wave activity increases. So anyways, that will do it for the Chucktown update. I hope that we were able to give you some insight on what Erica could do. I'll go back one more time to our latest tracks, and we'll end it right there so you can get an idea of what the latest tracks are going to do for Erica. And that will do it for the Chucktown Wind Report update. Have a good night.